car of mass 1400 kilograms travelling on a straight horizontal road. So straight horizontal road, car, and we've got some forces. It's 1400 kilograms, so it's 1400 G. Got normal contact force, I put it in even if I may not need it from the calculation. Resistance to motion of 600 newtons, so I've got 600 newtons going back to the left. At a certain, well, it's got driving force as well, isn't it? Driving force. And we've got its acceleration, so that's going to be resultant force is mass times acceleration. It's 0.3 meters per second squared. And we got engine, we got power of the car is 23, I'm going to put it into watts, 23,000. So I can find that. Power is FV, well in this case here that's dV. And we're trying to find out the speed of the car, so we're trying to find out what V is. So that is our unknown. So I'm going to have to get an equation with that in there. So power is FV, so that's 23,000. So I need to know D is 23,000 over V. And now I'm going to do resultant force times mass. Resultant force equals mass times acceleration. And I'm going to go in the direction of the acceleration. So what have I got? I've got D minus 600 equals the mass 1400 times by acceleration 0.3. I now worked out what D is because it's 23,000 over V. So I've got 23,000 over V minus 600 equals 420. And that gives me, if I add 600 both sides, that's 1020, and then divide, times through by V, and then divide by 1020, I get 23,000 over 1020, which equals 22.54901. So on. Okay, subsequently the car moves up a hill, so I'm going to need to draw this again. So hill inclined at 10 degrees. I need to put in my forces. I've still got 1400 G going straight down. I've got normal contact force up there. I've still got 600 newtons resistance, and I've still got D, but I want to draw that picture first. That's 10 degrees, so that means that's 10 degrees. And we've got to work out to calculate the engine's power, so I need to know what the force is, because power is force times velocity. So this is going to give me, first thing I want to do is go into constant speed, so I should put that on my diagram, constant speed of 12 meters per second. And if it's going in constant speed, that means the forces upwards must equal the forces downwards, and I'm going up the slope. So what force we got going up? We've got D, that's the only force going up. And what force we got going down? We've got the whole of that 600. And if I were to split this up into forces, I'd have that bit there going into the slope and that bit going down the slope. So it'd be that one there. And that is going to be 1400 G. So this is plus 1400 G. And it's opposite, so it's going to be sine 10. And that, but D, we know what D is. We knew what D from up here was. D is power divided by velocity. So that is power divided by V, and that equals 2,982.4529 times by V. That gives me power equals this number times by, and the velocity is 12, and that equals 34789.43597. Obviously you'll give these 3 significant figures, but I'll include all my figures in there. And that's one done.